Whether a child is impacted or not really depends on if the condition is autosomal dominant or autosomal recessive. So if it's autosomal dominant, where the person only needs to have one copy of the variation in order to be impacted, then there's a 100% probability that the child will be impacted. If it's autosomal recessive, where it requires two copies, then there's 0% probability that the child would be significantly impacted. Let's go on to the next scenario where we have mom and dad each have one copy. And if it's an autosomal recessive condition where you need two copies in order to manifest the symptoms associated with it, then neither of these parents are necessarily going to have any sort of symptoms. So I went through these like an algebraic. So if dad has one of each and mom has one of each, then the probabilities or the chances are one from dad, one from mom. So this person's green, they didn't receive any of the variations of impact. One from dad, one from mom. So one green, one red. Let's go on to the next layer. One from dad, one from mom. So that one looks like this. And then on this one, it's one from dad and one from mom. Depending on if it's a autosomal dominant or recessive, again, really will depend on if the person is impacted. Again, if it's autosomal dominant, then the child will be impacted here and here. If it's recessive, then the only significant impact would be here. So let's go on to the final scenario. One parent, and this can be mom or dad, so it doesn't really matter if you flop it around. One parent has one normal copy and one variant copy. The other parent has two variant copies. So when we lay it out, they get one from dad, one from mom. The next one from dad, one from mom. Next layer, one from dad and one from mom. So again, if it's autosomal dominant, then all of the children would be impacted, as would both of the parents. If it's autosomal recessive, then there's a 50% chance that the child would be impacted because they would require two copies in order to be significantly impacted by the decreased function of the gene. So I hope that answers that question for some of you. But what I do want to point out is that with conditions such as Gilbert's or the MTHFR, methyl tetrahydrofolate reductase deficiency, these are not life-threatening conditions. It's not like you're getting cystic fibrosis, right? Or some of these blood clotting disorders, which can be pretty serious. With both of these conditions, we can supplement. So we can make changes in our lifestyle, changes in our diet, so that the genes function or the impact of the decreased functioning of the genes is improved. Let's just talk about MTHFR for a moment. We used to get a lot of folate in our diet. We would eat more leafy greens, and leafy greens are foliage, which is where folate comes from. But we don't really eat leafy greens anymore. So the reality is most of us are not getting enough nutrients in order to support that pathway, regardless of whether you have the genetic variation or not. But if you know that you have that genetic variation, then you can intelligently make choices to improve the function by one, eating more greens, eating more foods that contain folate, and supplementation if necessary. All right, I hope that helps. If you have any other questions, please just feel free to drop them in the comments and I will go through them and answer them all to the best of my ability. All right, in good health. Bye-bye.